More than 400 million years ago, the Devonian oceans belonged to placoderms, armored-jawed fishes with bony plates around the head and trunk, but far more diverse than the image of slow, primitive tanks suggests. They hunted in open water, filtered plankton, moved across muddy bottoms, crushed shelled prey, and even preserved the earliest direct evidence of live birth in any vertebrate. For tens of millions of years, they were part of nearly every Devonian aquatic world, from tropical reefs to muddy freshwater systems. And perhaps no placoderm captures the imagination more than Dunkleosteus. For decades, it was often portrayed as a gigantic armored predator, reaching 8 or even 9 meters in length. A Devonian monster lumbering through the water like a living tank. But newer studies have changed that image. Instead of an elongated giant, Dunkleosteus may have been much shorter, more compact, and powerfully built, with the largest known individuals closer to around 4 meters in length. That revision does not make it less impressive. It makes it stranger. A shorter Dunkleosteus would have concentrated much of its body mass into a massive armored head and powerful trunk, creating a body plan with no close equivalent in modern oceans. Its ecological role remained terrifying. A specialized open-water predator built for sudden acceleration, precision attacks, and devastating bites. Its skull was a masterpiece of engineering. Massive articulated bony plates formed a head shield unlike anything seen in modern fishes. Instead of teeth, Dunkleosteus possessed sharpened, self-honing bony blades, capable of exerting one of the strongest bite forces ever calculated for a fish. Its jaw mechanism could open with explosive speed, creating powerful suction that pulled prey directly into its mouth before the crushing bite finished the attack. Imagine an apex predator combining the cutting jaws of a shark, the armor of a medieval knight, and the strike mechanics of a modern suction-feeding fish. In the Devonian oceans, Dunkleosteus was not simply dangerous. It was a completely different version of what a top predator could be. Yet the Devonian seas were not ruled by predators alone. Some placoderms evolved in directions so unexpected that they challenge our assumptions about ancient ecosystems. Titanichthys, a close relative of giant hunters like Dunkleosteus, abandoned active predation almost entirely. Its jaws were long but weak, lined with broad, flattened oral plates, unsuitable for slicing flesh. Instead, paleontologists now believe this enormous arthrodire was a suspension feeder, swimming slowly through warm, shallow seas while filtering plankton from the water. Reaching lengths between 4 and 7 meters, Titanichthys may have been the largest vertebrate of the entire Devonian period. Fossils from Morocco reveal that these ancient seas already supported food webs rich enough to sustain gigantic filter feeders over 380 million years ago. Nearby, another arthrodire turned predation into something stranger. Bungartius was not built around the clean slicing bite of a shark-like hunter. The bony plates of its snout formed a strange beak-like structure, almost like a pair of skeletal shears. It may have used this unusual mouth to cut, grip, or process prey in a way we still do not fully understand. Instead of fitting neatly into the image of a simple armored predator, Bungartius shows how strange placoderm feeding anatomy could become. Placoderms were not only changing feeding strategies, they were also reshaping the biology of reproduction itself. Metaphysis changed the story of vertebrate reproduction. Inside one fossilized female, Paleontologists found an embryo still connected by a mineralized umbilical cord, the oldest direct evidence of live birth in any vertebrate. More than 380 million years ago, some placoderms were already reproducing through internal fertilization and viviparity, far earlier than scientists once believed possible. It became a world where advanced reproductive strategies had already evolved. Other placoderms seem almost alien, even by Devonian standards. Dunkleosteus, with its streamlined body and elongated snout, looked uncannily like a cross between a swordfish and a goblin shark. Its anatomy suggests an agile open-water hunter, another example of placoderms converging on shapes familiar in later marine predators. Not all placoderms inhabited the open sea. Some dominated rivers, estuaries, and muddy freshwater systems. Among the most successful was Dunkleosteus, one of the most widespread vertebrates of the Devonian world. Its front half was encased in a rigid armored box, while its pectoral fins formed strange jointed appendages resembling armored limbs. These may have helped it maneuver across soft sediment or stabilize itself in shallow currents. With a small downward-facing mouth, Dunkleosteus likely spent much of its life near the bottom, sifting organic matter and tiny invertebrates from the substrate. If Dunkleosteus embodied the terror of Devonian oceans, Dunkleosteus represented quiet adaptability. Pterygids pushed armored fish anatomy in a very different direction. Pseudopterygids possessed broad, wing-like fins reminiscent of modern sea moths or flying gurnards. Its flattened body, ornamented armor, and upward-facing eyes suggest an animal adapted to life pressed against the seafloor, watching the water above while remaining nearly motionless below. A similar elegance can be seen in Dunkleosteus, instantly recognizable by the crescent-shaped armor plate adorning its head. Small, streamlined, and large-eyed, it likely moved with surprising agility through shallow Devonian reefs. While many placoderms are imagined as bulky armored beasts, Dunkleosteus shows that some were sleek, refined, and built for maneuverability. The ptyctodonts pushed this resemblance to modern fishes even further. Ctenurella looked remarkably like a modern chimera, with a slender body, large eyes, and smooth hydrodynamic proportions. Rather than tearing flesh, it probably used robust dental plates to crush shelled invertebrates hidden along the seabed. Some placoderms, however, evolved structures so bizarre that paleontologists still debate their purpose. Alien acanthus may be the ultimate example. This elongated arthrodire possessed an enormous spear-like projection extending from its upper jaw, creating a profile vaguely reminiscent of a swordfish. Was it used to slash prey, to intimidate rivals, to fight during mating displays? No one knows for certain. Its bizarre cranial anatomy demonstrates just how unusual placoderm diversity could become during the Devonian. Placoderms were not locked into one design. Some of their anatomical solutions were never repeated by later vertebrates. Equally strange was Gemwendina, a renonid placoderm with a flattened ray-like body covered in tiny tubercles. It glided close to reefs and sediments in search of food, superficially resembling modern batoids despite belonging to a completely separate evolutionary branch. Its fossils preserve rare details of skin and external anatomy, offering a glimpse of how unusual early-jawed vertebrates could look. Perhaps the most astonishing placoderm of all was Brindabelaspis, often nicknamed the platypus fish of the Devonian. Discovered in ancient reef deposits of Australia, it possessed a long, flattened snout, eerily similar to the bill of a modern platypus. Recent studies of its skull and inner ear revealed a bewildering combination of traits, with some structures resembling those of jawless vertebrates and others paralleling later bony fishes. Its elongated rostrum may even have housed sensory organs capable of detecting prey hidden beneath sediment, much like the electroreceptors of modern paddlefish or platypuses. Dunkleosteus is a reminder that the origins of jawed vertebrates were far more diverse and unexpected than previously imagined. By the late Devonian, placoderms had become far more than armored fish, occupying nearly every aquatic environment available. Then the systems that had supported them began to unravel. Oxygen dropped across large parts of the oceans, reef ecosystems collapsed, and food webs became increasingly unstable. The same seas that had allowed placoderms to diversify were changing faster than many lineages could survive. By the beginning of the Carboniferous, placoderms were gone, but their story did not end as a dead branch. In their armored heads, cutting jaws, strange bodies, and even their reproductive biology, we see vertebrates already moving far beyond simple beginnings. The animals disappeared. The direction they opened continued.